Alright, so I'm finishing off these review videos. So the directions on these under test were in numbers 15 to 18. Solve at least one by elimination and the rest by the method of your choosing. So since it's up to me, I'm going to do them the way I thought was the easiest. If you did it a different way, it's all good. So the first one, I see that one of the variables has a coefficient of 1 and is already by itself. So I'm going to use substitution. I hope that makes sense to you guys. So I'm going to take what we see up here, which y equals this, and I'm going to plug it in right down below into that equation. So 2x minus y will become 2x minus the quantity negative 4x plus 3. And that, my friends, my students, my whatever, all right? I don't know, some of you hate me, so, but it's not me, it's math. All right, that's where some of you messed up. Right here, there's a negative, and you got to watch out for that. So I'm going to distribute the negative, and I'm going to get 2x plus 4x minus 3 equals 3. So 6x, adding 3 to both sides, will be 6x equals 6, so x is 1. And if x is 1, I can plug x back into either of the top equations and solve for y. So y is negative 4x times, or negative 4x plus 3, so negative 4 times 1 plus 3 is negative 4 plus 3 is negative 1. So your solution should be 1 comma negative 1. There we go. Second one is also set up, I think, to substitute right away. But some of you might have gone through and said, oh, I hate fractions. And so you might have gone through and multiplied everything by 2 first. And then if you did that, you could have moved the x to the other side and solved it by elimination. I'm not going to do that. I'm going to do substitution again here. And I'm going to plug in this quantity in for y in the second equation. And when I do that, let me zoom in a little bit here. I will get the second equation to become 4 times the quantity negative 1/2 x plus 2, close parentheses, equals 6. And now I'm going to distribute that 4. So 4 times negative 1/2, half of 4 is 2, so negative 1/2 is negative 2. I got an x. 4 times 2 is 8, and that equals 6. Now there's something wrong with this statement. 2x minus 2x plus 8 is 6. Because right here, 2x minus 2x is 0x. A lot of you left the x in there. If the coefficients cancel out, you're left with 0x, which is no x at all. So then you have 8 is 6, which we know is a contradiction. And if it's a contradiction, then how many solutions are there? None. So your answer should be that or that, an empty set. All right? So those are 15 and 16. And I'd encourage you, even if you've done these before, try them again. You might not make the same mistake before you watch the next part of the video. I'm going to do 17 and 18 next. All right, so let me move that over. And I'll bring 17 into frame. All right, here's 17. And again, I think this one, substitution. I gave you a lot of nice, easily substitutable ones. So that goes in there. And because what I was looking for on 16 and 17 wasn't really the answer in the sense of ordered pair. There's a deeper concept there that I hoped you would arrive at. And you'll see it in a moment. 6x minus 2 times that quantity, that's not division, that's a minus sign, equals 8. 6x, distributing the negative, minus 6x, negative 2 times negative 4, plus 8 is 8. 6x minus 6x, the variables cancel out. If the variables cancel out, then the number of solutions is determined by what's left. If what is left is an identity, there's infinitely many solutions. This is an identity. So we have infinitely many solutions. But you cannot write negative infinity to negative infinity, because these infinitely many solutions are not on a number line. They're in 2 dimensions. So you have to write it as follows. The set of solutions is the set of ordered pairs such that the y is equal to 3x minus 4. So basically what you're saying is there are infinitely many solutions, but they're all on that line. All right? You could also say they're all on this line. It doesn't matter what equation you put after the condition bar, but you have to write it in this form because this is too vague. It's not every point on the whole ordered plane or coordinate plane. It's only the points that are on this line. Because what's actually happening here is these 2 lines are the same. These 2 equations are dependent equations, and they intersect everywhere on the line. On number 16, what actually happened here is these 2 equations were independent equations, but they had the same slope. So the system was inconsistent. The lines were parallel, and so there's no solution. If you graph these, you'll find that this line down here has the same slope as this line, but a different y-intercept. So you won't get any intersection. And remember, the solution to a system of equations is where their graphs intersect. All right, number 18, last one. This one I'm going to do by elimination. I'm going to take the top equation, and to get rid of the fractions, I'm going to multiply it by 6. So times 6, multiplying this by 6, multiplying this 1/2, I put the negative in front of the 6, and multiplying 6 times negative 2, I get, let's see, 3 goes into 6 twice, 2 times 2 is 4x, half of 6 is 3, negative 3y equals negative 12. The second equation, I'm actually going to look ahead a little bit and save myself a step. Because I know that this is a 4x, and maybe I want this to be, oh actually, when I multiply this by 2, won't this be a negative 3y? And that's a positive 3y, so I could almost make those cancel. Let me just do what I would normally do then. I'm going to multiply by 2, and I'm going to end up with 2 times x minus 2 times 3/2 y equals 2 times 0, which simplified is 2x minus 3y equals 0. Look at these 2 equations that result. Let me rewrite them as a system. If I want to do elimination on this system, all I really need to do, look at the y's are the same, but they're completely the same. I need them to be opposites, right? So I'm going to multiply the second equation by negative 1. So I'm going to change all the signs. 0 has no sign, so I don't have to do anything there. 0 is a neutral number. And then I'm going to add down. 2x, these will cancel, equals negative 12. So x is negative 6. And once you know what x is, you can plug back into this equation, this one, or this one, and find y. I'm going to plug back into this one here. So 2 times negative 6 minus 3y is 0. So 3y is going to be negative 12. Dividing by 3, we get that y is negative 4. And so our solution here is the ordered pair negative 6, comma negative 4. So that finishes up the section on systems of equations. Adios.